We are solving October 2023 Pure Math 4 paper. In the previous video we looked at question number 1 to 3. Now let's start with question number 4 now. Question number 4 is from proof. Prove by contradiction that for all positive numbers k plus 9 over k is greater than or equal to 6. So first we need to write the assumption first. For all positive numbers k plus 9 over k is less than 6. We need to take the opposite of it. Okay, and we are going to try to prove our assumption. Multiply throughout by k. Since k is a positive, you don't need to flip the sign when you multiply throughout. You get k square plus 9 is less than 6k. So k square minus 6k plus 9 is less than 0, which is basically k minus 3 whole square. If you try to factorize it, equation number 3, a is 1, b is negative 6, c is 9, you will get 3. That's the only value. So it's k minus 3 whole square is less than 0. But for all values of k minus 3 whole square will be positive. Positive or 0. If k is 3, it will be 0, but it will never be a negative number. So you need to write the conclusion now. This contradicts the assumption. Therefore, the assumption is wrong. That's the next line. And then finally the conclusion. For all positive numbers k plus 9 over k is greater than or equal to 6. That's how we apply the proof by contradiction. For every question you need to write the start of the proof, it is the assumption here, and then the body of the proof where we tried to prove our assumption but we ended up with a contradiction, and then the conclusive steps. That's all. We are going to move on to the second part actually. It's a one mark question. Show that the result in part A is not true for all real numbers. The result in part A is this: k plus 9 over k is greater than or equal to 6. We proved this is true for all positive numbers. Now they want you to prove that using counter example. They want you to prove it's not true for all real numbers. So when they say real numbers, there are negative numbers also. So if you try to sub in a negative number, replace k by negative 1 for example, you will get negative 1 plus 9 over negative 1 is less than or equal to 6. Minus 10, greater than or equal. Not correct, right? Because minus 10 is smaller than 6. So that's it. Just a one more question. Question number 5. We have a figure given with the straight line y is equal to x. Question says, figure shows a sketch of the curve with the equation y cube is equal to, y cube minus x square plus 4x square y is equal to k, where k is a positive constant greater than 1. Okay. Find dy by dx. We need to apply implicit differentiation. What is the implicit differentiation? You need to differentiate everything. When you differentiate y cube, it becomes 3y square. But the only thing, whenever you differentiate y, you put dy by dx with it. Minus derivative of x square plus you have 4x square y. You need to apply product rule. How to apply product rule? Keep the first function as it is, differentiate the second one, but you need to put dy by dx with it, plus keep the second function y as it is, differentiate the first one, 8x, 4x square becomes 8x is equal to k becomes 0. They want you to find dy by dx in terms of x and y. So there are two like terms, one here, another one here. take dy by dx as a common factor out, you will get 3y square plus 4x square times dy over dx is equal to 2x. This 2x comes here, and then 8xy comes here minus 8xy. So divide by 3y square, divide by 3y square plus 4x square, you will get dy by dx already. Dy over dx is equal to 2x minus 8xy divided by 3y square plus 4x square. That's all. It's a 5-mark question actually. You see, 5-mark question, you have written only 3 lines to get the 5-mark question. Because as per the marking scheme, you'll be given 1 mark if you differentiate this correctly, and then 1 mark for applying the product rule here, 1 mark, and then if you have done the rest of the things, everything together correct, 1 mark, and then you write this step, 1 mark, final answer 1 mark, total of 5 marks. So do not worry that you have written only 3 steps here for a 5-mark question. Let's move on to the next part of the question. Given that the normal to C at P has equation y is equal to x, find the value of k. Now look at the diagram. There is a point P here. This line is a normal actually. Normal to the function. What's the slope of the line? Slope of the normal line is the coefficient of x1. So what would be the slope of the tangent? Negative reciprocal of this, -1, right? Slope of the tangent is -1. What does that mean? The dy by dx at P, the point P is equal to -1, right? So if you look at the point P lies on the line y is equal to x. So you take any point, the x coordinate and the y coordinate will be the same. So y will also be x. So in dy by dx we got from the previous part, I'm going to replace y also by x and equate it to -1. We got dy by dx here, 2x minus 8xy. 2x minus 8xy, replace y by x, divided by 3y square, which is 3x square plus 4x square is equal to -1. 3x square plus 4x square, 7x square, bring it here, it becomes minus 7x square. And on top you have 2x minus 8x square is equal to minus 7x square. Solve for x. So probably you can bring it here. You will get, put everything on side, you will get minus 7 plus 8 is 8x square minus 2x is 0. X times x minus 2 is equal to 0. X is equal to 0 or x is equal to 2. What does that mean? There are 2 points, x is equal to 0 and x is equal to 2. But definitely from the figure, this point is x is equal to 2. So at this point, so the point P is basically 2, 2. Now the point lies on the curve also. So I'm going to replace x by 2, y by 2 into the curve, equation of the curve to find the value of k now. So I'm going to take the equation of the curve, y cubed minus x square plus 4x square y is equal to k. Replace x and y by 2. So 2 cube minus 2 square, 4 times 2 square times 2 is equal to k. So 2 cube is 8 minus 2 square plus 4 times 2 square times 2. So the value of k is equal to 36. That's all. That's how you solve it. The line L1 has equation 2, 3 minus 7 lambda times this. L2 has equation this. L1 and L2 meet at point P. State the coordinates of point P. Usually, it's a 1 mark question surprisingly. Usually how do we find the point of intersection? we equate them. Let's say we frame an equation using this 2 plus lambda is equal to, frame another equation, equate the corresponding elements, 2 plus 4 mu. I'm just trying to explain something, just pay attention. This is what we are going to do to find the answer actually. This is the usual method. 2 lambda is equal to 3 minus mu, minus 7 plus 2 lambda is equal to minus 7 plus 8 mu. Take any two equations, find the value of lambda and mu, sub in into the third equation, and if it satisfies the third equation, that means there is a point of intersection. So to find the point, you need to either sub in lambda here or mu here. That's the usual method. But this question got only 1 mark actually. So we are not going to do all this thing taking like 5-6 minutes. Then how do we find the point of intersection? If you observe the equation of the straight line closely, the first one, usually if a straight line passes through a point A with position vector A, let's say, and the line is parallel to another vector B, you can write the vector equation of the straight line as A plus lambda B. So the first vector is the point that lies on the straight line. So for L1, the point is 2, 3, minus 7. L2 also 2, 3, minus 7. What does that mean? This is, let's say L1, there is another line also passes through the same point. So the point of intersection is this point 2, 3, minus 7. So straight away you need to write 2, 3, minus 7. That's all. That's just a 1 more question. Part B now. The angle between lines L1 and L2 is theta. So you need to take the direction vector of these two lines. The direction vector 1, 2, 2 and 4, minus 1, 8. You find the dot product of it because the formula to find the angle between two vectors is A dot B, that's the dot product divided by modulus A modulus B. So first let's find the dot product. Take the direction vector of L1, direction vector of L2, find the dot product. 1 times 4, 2 times minus 1, 2 times 8 is 16. We'll get 20 minus 2 is 18. That's the scalar product A dot B. Now we need to find the modulus of both vectors separately. So cos theta is going to be 18 divided by the modulus of the first vector is 1 square plus 2 square plus 2 square. Modulus of the second vector is 4 square plus 1 square, or you can write it as minus 1 whole square. That will give you the value of cos theta. So it's 18 over square root of 1 square plus 2 square plus 2 square times square root of 4 square plus 1 square plus 8 square. You get 2 over 3. That's all. That's the answer here. Part C. In part C it says, given that Q lies on L1, okay, we know the equation of L1, R is equal to 2, 3 minus 7 plus lambda times 1, 2, 2. When you sub in lambda is equal to 6 here, you will get OQ vector. OQ vector is, replace lambda by 6 and simplify, you will get 2 plus 6, 3 plus 12, minus 7 plus 12. There is and then wait, it says given that R lies on L2 such that triangle QPR is an isosceles triangle. You can draw a little figure to understand it. Let's say this is line L1, this is line L2. They are both intersecting at point P. Now Q lies on L1. There is a point R lies on L2 such that PQ is equal to QR. That means this triangle is an isosceles triangle. That's what the question says. You need to find the area of the triangle. If you know the length PQ, that would be the same length PR also here, and we already know cos theta, the angle between them. From there you can find sin theta, so the area is half AB sin theta. That's what we are going to do. So first let's find the length PQ. We know OQ vector, so PQ vector is equal to OQ vector minus OP vector. Basically from here we are going to minus off this 2, 3, minus 7 because that's the position vector of P. Or from here you minus OP vector 2, 3, minus 7. It's the same thing. So you are going to get 6, 12, 12. That's PQ vector. So modulus of PQ is, so modulus of PQ vector is equal to square root of 6 square plus 12 square plus 12 square is 18. So this length is 18, this is also 18. Now we need to find theta. From the previous part we got cos theta already. Cos theta is 2 over 3 we got. So using the trigonometric identities, we have already got cos theta is 2 over 3. We know sin square is equal to 1 minus cos square. So from here you find sin theta. Square root of 1 minus 4 over 9. Which is root 5 over 3. Square root of 5 over 3. Now the area is half AB sin theta. Half AB sin theta. So this answer times 18 square times half. We need the exact area. We don't want this answer. We don't want the decimal number. So what I'm gonna do, I'm gonna write it as first without square root of 5. I'm gonna simplify it. So it's 18 square divided by 2 times 3 is 54. So you will get times root 5, 54 root 5 square units. That's the area. That's all. Now the next part says find the coordinates of the possible positions of R. From the figure we know these two lengths are same. So basically modulus PR is same as modulus PQ, and we know modulus PQ is 18. Let's find PR vector. R lies on L2. The equation of L2 is 2, 3 minus 7 plus mu times 4 minus 1, 8. So PR will be, PR vector would be just this, 4 mu minus mu 8 mu. If you ask me how I got just this, PR vector is basically OR vector minus OP vector. OR vector is this whole thing minus OP vector is 2, 3 minus 7. So these two will be cancelled. So you will be left with mu times 4 minus 1 minus 8. The modulus of it is square root of 4u square minus u square 8u square. You can take u square as a common factor out. It will come out of the square root as mu. It's not u, it's mu. Mu square root of 4 square plus 1 square plus 8 square is 18. Divide by this square root. 18 divided by this. 18 divided by square root of 4 square plus 1 square plus 8 square is plus or minus 2. We take plus or minus here because to find the two possible positions of R. So sub in these values into the straight line, you will get two possible positions of the vector R. So when you sub in mu is equal to positive 2, the point R would be, I'm going to take it as R1. It would be replace mu by 2 here. So 2 plus 8 is 10. 3 minus 2 is 1. Minus 7 plus 16 is 9. When you sub in mu is equal to minus 2, I'm going to take it as R2. 2 minus 8, 3 plus 2, and then minus 7 minus 16. These are all the two possible positions of R2. Now let me explain something here. This is length actually, PR. And you might be wondering, why are we taking plus or minus 2? We are talking about a position vector of R actually. The R can be here, or if the line L2 is here, the R can be here also. So there are two possible positions of R. To find the both possible position, you have to take the square root as plus or minus. Then only you will get the two possible position. So we got the answer already. This is the answer. That's all.